Hi all, welcome to the second of the videos we've got doing a review of the natural hazards topic. Now this video is going to look at volcanoes, their formation, the impact that they can have, and we'll talk largely about the Mount St Helens eruption in 1980, which is your case study for this topic. Now, to start us off thinking about the formation of volcanoes, we've got this diagram. Now, I'm going to open with a couple of points just before we get into this. One, the diagram is okay. It will serve our purposes, but please bear in mind that the formation of volcanoes is very, very complicated. There is a huge amount to it. There's a lot of different types of volcanoes, different types of eruptions, things like that, which could, render this diagram completely irrelevant. However, for what we are looking at, this diagram is nice and straightforward. It gets to the point of one particular type of volcano and its formation, and if you had to discuss it in the exam, this is the type that you would actually want to look at. So it's just a little bit of a warning in case anybody is looking at things online and looking at different texts and they see things and think that's totally different to what I was saying in this video. It's not to say that what's here is wrong, it's just that there's a little bit more to it than what we're going to discuss today. Now, to start us off with this, we do have this diagram here, which is looking at, let's say this is a volcano on the edge of a subduction zone. So, because that's very relevant for our Mount St Helens example. So over here somewhere, we've got our oceanic plate, which is being subducted beneath this plate here, which is our continental plate. And as this plate subducts, it's going to be exposed to high pressures, high temperatures. It's going to melt, and this material is, bubbling up into the continental crust, and it forms our magma chamber. Now, one quick distinction to get out of the way now. The difference between magma and lava is pretty straightforward. They're both molten rock. Magma is molten rock that's inside the Earth's surface. Lava is molten rock that's been extruded onto the Earth's surface. So magma is simply still underground. Lava is above ground. So we've got this, and if we imagine for the sake of starting that none of this on top is actually here yet, let's just say for somehow, magically, we've got a perfectly flat bit of continental plate, we've got a magma chamber underneath it. Now eventually, we're going to see pressure build up, and eventually it's going to break through the Earth's surface. Now that could be assisted by earthquakes and things like that, certainly that's the case with the Mount St Helens eruption. Anyway, it breaks into the Earth's surface, and we have some of this material is erupted. So we're going to have some of the actual magmas erupted, and we're going to have a huge amount of ash erupted as well. Now, as the magma gets erupted, it hits the Earth's surface, and it starts to cool. As it cools, it becomes rock, and it's going to become an igneous rock. And that's going to form our first layer of our volcano. It's going to form the first layer of our volcano. Now that's going to be enhanced by ash that's going to fall on it as well, and that ash is going to be compressed, and it's going to form some rock as well. It's going to form igneous rocks as well, things like pumice, things like that. Now, volcanoes will erupt again and again and again over their life, if you want to think about it that way, and that life can be largely determined by the size of the magma chamber that the volcano has at its disposal. And some of these magma chambers are huge. We could be talking millions of cubic meters of magma. So you can have volcanoes that live, that have periods of eruption and inactivity over the course of hundreds of thousands, millions of years. And as you have eruption after eruption after eruption, you get more and more layers added on. And this eventually forms our volcanic mountain. Now, a couple of things to add at this point. That fairly straightforwardly is how you get a volcano, in terms of how do you get the massive mountain that's spewing lava. That is simply put how it happens. But one thing that's important to remember is that not all volcanoes are massive mountains that spew lava. Actual lava producing volcanoes are not the only type of volcano you get. You've also got volcanoes that, you could have pyroclastic flows, you could have lahars, which are volcanic mudslides. All this type of stuff are still volcanoes. Just because lava doesn't come out the top, doesn't mean there's not still a magma chamber driving the eruptions. And also you get some that, never get this big. Particularly if we look at diverging plate boundaries, you can have volcanoes that only ever get, pretty small, and through different processes, they remain at that height. But for us, we think of our stereotypical volcano. We think Mount St. Helens. Most of the volcanoes along the Andean mountain chain are all going to be like this. Now, if we think about Mount St. Helens, there are three main areas that we need to think about. Now, you should have already covered these in your case study, and by most of you have. I've seen most of your case studies. More or less everybody has had feedback by this stage, and you should really have acted on it as well. But we look at causes, impacts, and response. Now, if we start by looking at causes, here is a diagram showing us the kind of Mount St. Helens, the region, the general area that we're talking about. And the cause is pretty straightforward. We have got over here, out just next, in the Pacific Ocean, but we've got the Juan de Fuca plate. It's being subducted underneath the North American plate, and as this plate goes down, it's getting exposed to that high pressure, high temperature, it melts, we get our magma chamber forms, and this feeds Mount St. Helens. And that's, in terms of causes, why did it erupt? That's really it. Now, in terms of the specific 1980 eruption, it's also aided by, we had a period of earthquake activity, which is very, very common when we've got volcanoes. And again, very, very common here, because we need to remember this whole area is being subducted. It's moving underneath the North American plate that Mount St. Helens sits on. But remember what I said in the last video. That's not a smooth motion. This gets stuck. It moves a little, gets stuck. Pressure builds, and then boom, you get big movements. As that big movement happens, it can free up material. It can create weaknesses in the Earth's surface and the geology. And if you've got a great big mountain that's under quite a lot of pressure from, a huge magma chamber underneath it, that can lead to a volcanic eruption, which is very much what happened in the Mount St. Helens case. Now, if we think about some of the different impacts, now before we talk about these impacts in detail, an important point to remember, you can use these impacts, the detail, under any of the headings that you can successfully justify them. We've got social, economic and environmental as our headings here. So things that affect people, things that affect money, the economy, and things that affect the environment. But if you can successfully justify one of them being in a different heading, then that's fine. And you will get, it's very likely that you get asked a question on impacts in the exam. So it's important that you know how to do that. Now, another health warning, if you will, with this, is that some of these, the detail of these changes, depending on the source that you get the information from, the detail can change subtly. Death counts is a really, really common example. I've got, as a social impact, 61 people killed. Now, realistically, for Mount St. Helens, as long as you are within the kind of 50 to 60 range, you're fine. It doesn't really have a huge difference what exact number you come up with in there, as long as you are in the right ballpark. If you turn around and say, 5 million people died when Mount St. Helens erupted, that's clearly just incorrect. So it's just as long as you're in the right ballpark. But we've got other ones in there for social, 198 people needing rescued, buildings/trees flattened by the explosion when the eruption happened. Now, in this, for social, we're really more talking about buildings, homes, things like that. Mud flows, destroying bridges, houses, etc., etc. About, people's ability to move around, to evacuate, etc. Economic, nice easy one to start with. £500 million worth of damage to farm machinery and crops. Again, obviously, value for that, if you find it in dollars, it's going to be different to what I found in pounds. But it's about a specific idea of how much money that has cost. Cancelled flights, that has an impact on the economy. And, I've put anything you can justify financially, because that's what economic ones are. The environment ones, nice, easy, straightforward ones. The mountain physically got smaller by nearly 500 metres. That's a huge environmental impact. It's a huge change to the landscape. It caused a huge landslide. There was a huge amount of death to animals, wildlife that live in the area surrounding Mount St. Helens, and plants as well. The more or less every tree and every animal, every bit of plant, every bit of life living within a 25-kilometre radius of the volcano was maybe not killed, I maybe oversold it slightly on this slide, but certainly, huge amounts of impact on them. And again, I've got mud flows, choked rivers, devastating fish stocks. You guys should have comments about, fisheries and the amount of salmon particularly that died. Now this is a small amount of the impact that Mount St Helens had. You should have far more than this in your actual report, but you can certainly use this to add on to your report. Now, response. Now, with the response with Mount St Helens, I've split it up into 3 sections. So before the eruption, immediately after it, and longer term. So now, before the eruption, there was a response. Volcanoes, you can tell when they are going to erupt. They start to puff smoke out of the top. They physically swell. There's earthquake activity. All this type of stuff that gets noticed. Now, and because of this, in Mount St Helens, they actually established 2 exclusion zones. So you had this red zone immediately around the volcano where you were not allowed to go at all. And a blue zone where, if you had essential work to get done, you were allowed in, but, you weren't allowed to go and have a walk and take pictures. And that led to, evacuations and stuff like that, which were obviously a little bit successful. However, the big issue with this, and this would come into your evaluate how effective the response was, people ignored them. Mount St Helens is in the middle of wilderness. It's very, very hard to keep people out of an area this size. I've spoken to some of you guys about, if you imagine Goat Fell, imagine you decided one day no one was allowed to go up it. How would you enforce that? How would you physically stop people? It would be very, very challenging. Now, immediately after the eruption, the National Guard were drafted in. They flew helicopter rescue missions. They got people out. They also issued emergency supplies, food, water, medicine, etc. Gas masks to help people with, inhaling the ash and some of the poison gases that volcanoes can emit. And, actual physical help, shoveling up ash. It is a huge issue. Roads get closed because of the volume of ash that falls on them. And then longer term, we're talking about rivers needing to be dredged so that they can be used again, trees being replanted, infrastructure being rebuilt. Very, very important that all this stuff happens. And now the mountain is now under constant surveillance by the US Geological Survey so that they've got as much warning as possible of another eruption. Now, this has been a fairly brief rundown of how volcanoes are formed, the impacts, or the causes, impacts, and response to the Mount St Helens eruption. And you need to remember that the key part of this, the bulk of the information, this should be in your case study that you've written up and had reviewed by me. The vast majority of you are certainly in that position now. But remember, if you do have any questions, if you have anything that you want to discuss about this, just come and see me. So that wraps this video up, guys. So thank you very much, and I will see you soon.